excited to have Martin Carver with us tonight. Martin is the excavator of Sutton Hoo and Port Mahomet, among many, many, many other sites and accomplishments, and I've asked him to say a few words of introduction about himself.
Thanks, Lisa. Well, I'm excited about being here. You probably don't realize how well known you are, DigVentures. And I like to think of you as, I mean, this is the first time I visited this setup. So although it's the first day for many of you, it's also the first day for me. And I think it's a very exciting initiative. And I like to think of us, me while I'm here, as a kind of research partnership. And I know you're all very different levels of experience, and some of you are all a little bigger, and some have just arrived, you know. I know that. But I still think we're in the same game. And I think what Lisa asked me to do, so I hope it was to try and indicate some of the things that are going on in excavation in world terms. Now, this is not a treasure hunt. This is not a tour of great monuments. This is not even a tour of great digs. This is a tour of how excavations are done. And because I think when you come here for a day or a weekend or a week or 2 weeks or something like that, you see quite a lot of a small bit of ground, and you get very, very, very fond of it. I'm just warning you, especially if somebody gives you a feature to dig, you sort of hang on to that feature with white knuckles, and you don't want to be ever moved off it. So that's what happens. But somehow, with the rush of getting an excavation to work and to happen, then you don't often get a chance to get exposed to the bigger picture. So I'm going to do a little bit of a world tour with you to show you the kinds of thing people are doing when they investigate the past using excavation, and try and throw a few principles and ideas at you so that you feel you belong to a wider and deeper profession that is developing very, very rapidly. And in fact, this opening picture tries to sum up what makes archaeology happen, what makes excavation happen in particular. In the first place, we need to want to know something about the past. And you're in a splendid position here because you're in a site that's been excavated and shown to be pivotal for the understanding of the Bronze Age, not just in Britain, but in Europe. So to find some objectives is not too difficult. The way that the excavation then happens depends to a very large extent on the terrain, by which I mean what the ground is like, whether it's wet, dry, clay, chalky, gravelly, sandy. It determines to a great extent the techniques that you use and what it's possible to see. And then the society that we live in, this is the bit that has been disregarded in countless digging manuals because a lot of archaeologists used to think of themselves as scientists in the kind of Ghostbuster sets, like Black Wolf, I'm a scientist, you know. And now I think the realization is coming partly due to the initiative of some of the people in this room, that it's not only important to involve the public in what we do, but in fact the public influences what we do in a very, very material way. So in that, we're not like nuclear physicists, we're not like chemists. We work inside a social context. These people are looting a site in Cambodia, and here we are doing something extremely different, where we're encouraging respect for the evidence, but opening up the investigation to partnership. And I think that's what makes it exciting. Can I have the next one then, Lisa?
Yeah. And also, can I?
Oh yes,
Martin
yeah.
said we're allowed to ask questions at any time.
Yeah, interrupt me. If you think I don't want to hear any more, you just have to say, stop. I want you to talk about something completely different, or I want you to answer this question. And I don't really mind this at all. Okay, and the same with you, Liz. If you think, we could, I'm here for you I was asked to tell you something about myself, wasn't I? Did you say that?
Yeah, a little bit, if you felt like it.
I'll do that. I'll do that at the end, if you don't mind. Okay. So first, I'm going to talk about terrain. I'm going to talk about the differences in different parts of the world and how people try to excavate. I'll show you some extreme examples. Okay, you see here, there is a tell, there is an excavation on permafrost, there is an excavation inside a jungly area. Very, very different, all completely different kinds of evidence, different approaches. Next one, please. And we go to the desert, first of all. Now, the great deserts of the world have also captured some of the most interesting, the traces of some of the most interesting people. But they are amazingly slight. So when you go to the deserts of Australia and talk about excavation, they don't do excavation. What they do is they're looking at huge deflated surfaces where there's the odd stone tool like you found today and a few flakes, and they're scattered and they're very easily displaced. And this is actually Arizona. This is a photograph of Geronimo's Wickiup, which was photographed in 1886, so before Little Bighorn. And this is where those people lived, and they lived in this kind of bender with lots of sticks and cloths and all sorts of things. But all that gets scattered by the desert winds, and all you get left is, next one please, you just get little kind of suggestions of where there has been a tent. And in fact, if you look at your campsite when you've gone, you will see suggestions of where there has been some tents. they won't last very long, but you will see some, like sort of a border of empty bottles, brown, where the tent was. And this is the same idea. These are borders of stones, which show, next one please. So these are teepee rings. And then to go from one extreme to another extreme, this is Vladimir Tulko's excavations in Siberia, where his problem is that everything is deep frozen. And in some ways it's good, because you get lots of very, very good preservation of the wood. Finding this site is a nightmare. They look at where meltwater comes out, and then they find flints in that meltwater, and they try and follow it back into where it must have come from. So next one, please. What they tend to do is to wait for the top to freeze. Sorry, beg your pardon. Wait for the top to thaw, and then excavate it, and then it freezes again while the other one's thawing and so on. So they gradually move across the territory. Now, some of these things are 5 or 6 meters down under the frozen ground. So here you see some people in a boat, and they're coming sideways at one of these Siberian sites. Next one, please. And this is how they dig them. Basically, you have a hose, and you kind of melt the cliff, and then leap out of the way. And Tulko's description of this is well, you can imagine sort of very Russian deadpan. We find that the earth sometimes collapses in very big pieces. This can be dangerous. So they're swilling down here, and what they try and do is record. Here we are, look, they've got a face there. So they record before the next bit of unfreezing. I mean, incredibly dangerous, very difficult. And yet, how else are you going to get at these people who are now 4, 5, 6 meters under frozen ground? Next one, please. So these are just a couple of examples which were just to emphasize the general idea that everywhere you dig, the soil, the subsoil, the makeup of the ground is different, and so it has to be approached in a special way. Now, this is just really for those who have literally just arrived in archaeology. It's sometimes difficult to know why you're digging where you are digging and digging in the way you are digging. And this kind of thing, which is, I don't know if it's possible to drop it about 1 millimetre there, because it's not really...
I'm afraid to touch it.
Yeah, okay. It says, on the top here, it says reconnaissance, So basically we follow a staged procedure in every investigation. And we take a piece of landscape and investigate that landscape from the air or the ground. And that process discovers sites. Then when you've discovered a site, you then do lots of survey of that site, and that tells you how much has survived in that particular place. Then you have a thinking period, which sometimes is separated from these first two by 6 months, a year, 2 years even, when you prepare the design. When you're preparing that design, you have in mind your objectives, your terrain, and your social context that you're working in. You put together, basically, programs of work. Then you carry them out, and that very often involves excavation, but not always. Sometimes an archaeological program can be only survey, and it can be specially designed to have the minimum impact on the ground. So this phase is absolutely crucial, this design phase. We are a design subject. We're like architects. So we're not just stumbling along hoping to find something. We're designing what we need to know about and how to do that. That generates a whole lot of records, and you've already started making some drawn records, written records, photographic records, video records. All those are different kinds of records where you try and remember exactly what things looked like when they first appeared. Sorry about that. When they first appeared. And that constitutes a set of information which is sacrosanct. That's what you've turned the site into. You've turned it into a set of records. So people say excavation is very destructive. But it's not very destructive. It's destructive of strata, but it's creative of result. And lots of other sciences are like that too. So we've nothing to be ashamed of if we go digging and dig as well as we possibly can and produce a set of records from that. And then that goes to be archived, which you heard about last night, and then published. So that and nowadays we publish in lots and lots of different ways. So they're not all great big unreadable books. They are sometimes quite small unreadable books. Sometimes they are really small but very readable books. Sometimes they're films, sometimes they're on the internet and so on. But we're always experimenting in ways of communicating. And you've got a smashing opportunity here. Well, I say opportunity, you're already using it because you've got an internet outlet which is reporting on what the excavation is doing, what people are finding. And then when you get to the end of the season, you've got a very good chance of reporting to everybody who's interested, not just everybody who's been on the dig, but everybody, what happened at Flag Fen this summer. Now, lots of people do this, but they tend to do it in a rather kind of, these are my holiday snacks attitude, rather than, this is a report that should be respected, and it's being done by people who went there to find out about the past. Next one, please. So, if you agree with those stages as being a kind of helpful idea about how the investigation works, let's just look at some examples of what's done these days. First of all, there are quite a lot of sites that can be seen, or sets of landscapes that can be seen from satellites. And you can either have old satellite photographs. In the 60s and 70s, satellites whirled around the world looking for rocket sites and that kind of thing. They've all been declassified now, so every part of the world virtually has had a photograph taken of it in that period, when the Cold War, slightly earlier, when the Cold War was at its most active. A tremendous archive of photographs. They're called Corona, and then you can still hire time on a satellite. It's not cheap, but you can, and get a multi-spectral version of the landscape that you're working on. This is all done in advance, helps locate things, particularly on a big scale. So this here is the road system around Tel Brak. Tel Brak is a big Bronze Age site in Syria, and these are all the roads showing up that led to it in the Bronze Age. Let's have the next one. Okay, flavour of the month now is LIDAR. Everybody loves LIDAR. And LIDAR is a form of survey which you do from an aeroplane, and basically it records the humps and bumps on the ground with great precision. So even if it's very, very slight surface of the ground, apparently you're looking at just a grassy field, you can see the old line of the plough soil and sometimes buildings and so on. Anyway, the exciting thing about this is they've now learned how to do it through trees. So actually this is a picture of what's under that. So the lidar puts a kind of laser beam down. Some of the laser hits the top of the trees and bounces off, and some goes through and hits the ground underneath. And then digitally, as they blithely say, which means somebody's done a lot of mathematics, digitally, by knowing the height of the trees, roughly, you can subtract one from the other, and you get the plan of what's underneath. Magic. Next one, please. And this is one of Catherine's students, Mary Chester Caldwell, who did a lovely PhD thesis on metal detector finds. This is, you probably talked about your relationship with the treasure hunting fraternity. Well, like every other fraternity, the treasure hunting fraternities, it's not all bad, and it's actually become much more partners with us than it used to be. And that's because the finds are reported. And that's because the locations of the finds are also reported. So you've got quite a lot of information about 70,000, was it last year? It's something like that, 70,000 finds from England last year that are found by metal, reported by people with metal detectors. Here's one here. And what Mary did was to plot a lot of the Anglo-Saxon finds and come up with all sorts of settlements that people didn't know were there, and some cemeteries as well. So in other words, mapping the Anglo-Saxon landscape from little bits of metal that get dropped off people while they're walking the fields and jumping about. Next one, please. So when it comes to site survey, we have now some of the most sophisticated machinery. This is Immo Trinks, who is one of the leading lights of the Ludwig Boltzmann Institute, chatting to Brendan about. They do a lot of different kinds of machines, but radar is their special thing. And they've now got radar. They've got radar that goes deep, and they've got radar that goes shallow, and it's very precise. Now, what you have to do, if I do this,
Yes.
I'm going to have to stand in front of you, sorry about that. But in order to do this properly, that's the one there, isn't it? This is what you see from this radar in the time slices going down. I'm going down about 20 centimetres at a time. And the detail is absolutely astonishing. Now I'm going underneath that burial mound now. Still see the chain, but I'm going underneath it. And I'm now going down towards the subsoil. And eventually we'll get into the subsoil. And that is about 50 or 60 slices through a burial mound. Now they can do this for all sorts of kinds of feature. And the new one with the 8 centimetre spacing on the antennae goes much shallower. So they've just done a Roman villa where you can see everything. You can see the hypercourse. It's really astonishing. Now, I need hardly tell you that this is really helping to, not only to revolutionise archaeology in the sense of, oh, we can find sites we didn't know were there, but also we can dig as much as we need to dig. We don't need to just try and dig everything. I mean, this is going to give us a great deal of detail. So from management point of view, as well as from a research point of view, and from the point of view, I think, also of social awareness, I think these gadgets are becoming really, really important. They've always been with us, and we've been very pleased to have them, but I think now they're becoming that much more sophisticated. One of the things we did at Sutton, which was really very successful, was inviting the owners of different machines to come round. I've just been chatting to Brendan about this, and we invited them to come round and do their geophysical surveys on the area that we wanted to survey. So, and we pointed out to them that they were in competition with each other. So we didn't have to pay them. They wanted to come there, and they wanted the publicity of having best machine. But we also got an awful lot of cranks, because one of the people we got was Mr. Lovegrove and his hazonometer. And his hazonometer was like a kind of it was a water pistol with a micrometer screw gauge, sellotape to one end. And he brought a gang of admirers with him. They thought it was wonderful. And I said, "What does it do?" He said, "It just detects anything." screw gauge. And then he got into the hazonometer position, which is like this, with his sheet like this. A bit like something out of detective story, and then he started to vibrate. He point to a burial mound. So I said, okay, what about wood? Can you do wood? Now behind him is an enormous wood case called top hat wood, immense wood at South Maine. And he started to point and said, no, put it that way. So he pointed at the wood and he said, nothing here at all. So I said, and the trees? So, oh no, he doesn't do that. He only does old stuff. Anyway, eventually, I said to his companion, this thing doesn't work. And they said, yes, but don't tell him, it's his pride and joy. I said, that's fine, as long as I'm not paying for this. And that was when, Francis Prygon got him later on and rang me up saying, I've got this new gadget, is it good? I said, no. Anything at all. Next one, please. So these things are looking pretty hot, and we've been looking at all this to start with, and this is the great stage 3, the project design, which I'm really keen on these things because I think it's up to us to tell people what we're going to do before we do it, and then that leads to the kind of agreement from not only from the state, which controls our resources, county archaeologists, local authorities, but also members of the public. So I am also a very keen advocate of having a project design made public. Now you've made yours public, it's on the website, and you are only, I think, amongst the handful of people who have ever done this. I mean, I've published all my project designs, but I thought, when I did it, I thought, well, that's good, now I'm going to do this. But they didn't. They rather took the view I was a bit of a mug, for saying what I was going to do before I did it. I think that's cynical. I think on the whole, we have the same obligation as an architect has. An architect is going to put up a building, they deposit the plan, the blueprint, the maquette in the local authority, it's on public display, everybody can look at it, everybody can complain about it. Now in a way, you see, this also introduces an element of quality control, which means that every excavator has said what they're going to do so other people can look at it and decide whether it's enough. And in a way, that's how we get to control developers. When developers want work done on the cheap, by publishing the project design or making it public, putting it in the public domain, other people, yes, archaeologists too, can go there and say, that's completely inadequate. Don't give them planning permission before that archaeology is improved. Yes, I think it's a bit ideal, but that's what I hope is going to happen. So project design then produces a research program, which can be survey as well as excavation. So here you've got survey boreholes, is it? Auger holes? I think you've got test pits as well as an excavation area. So you've got quite a lot of different things going on, and that's part of the research program. And then you've got a resource management program, which is conservation, what is going to be conserved, what is going to be dug. And you've got a presentation program, which is pretty easy because you're already a presenting site. You already have a museum, you already have a visitor centre and so on. So to a certain extent, some parts of the project design are already written. But that's the document. I think that's the document which makes archaeology real and makes other people believe that they are party to it. They're not victims of it, they are party to it. Okay, let's have the next one. Now, when it comes to digging, I'm just going to focus on that for a second. I think the next bit of my talk is to try and get across to you the idea that although there are certain set ways of digging, and Britain is particularly keen on certain types of excavation, like stratigraphic excavation recorded in single content, which is a very good way to learn, I have to say, very good way to learn. It isn't the only thing everybody ever does, because they can't do, because the terrain sometimes varies so that they can't do it. So some of these methods, some of these approaches vary because the ground is different, and some of them vary because the country's got itself stuck in a total rut and doesn't understand that we are a creative subject as well as a scientific subject, and therefore every excavation demands a different bundle of techniques, a applied in a special way which is going to maximise the information that's coming out. And I think some of you who've just started out will think, yeah, well, obviously, but unfortunately it isn't accepted by everybody in the profession. So here's the box system in China, which they think the Russians invented, and they stick to it. This is the Schnitt system in Germany, where they just cut everything flat into vertical and horizontal slices or schnitz, and they love doing it that way, and they think this is scientifically better than our system because it's checkable. So they have lots and lots of horizontal sections like you were drawing today, plus the, vertical sections like you're drawing today, plus the horizontal sections. This is the box system, which they love in the United States, where you do random test pits all over the area you want to investigate, generated by a random number system, so you put them in different places according to what the random number table says. And this is the more familiar to us area excavation system, where you start by opening the site up, look at it, look at all the anomalies, draw them, and then start excavating individual features stratigraphically. That's how you do it in the countryside. So just to interrupt if any of these things baffle you, and this is a little map that I drew which just showed how people prefer to dig in different parts of the world for all those reasons that I've mentioned, tradition, how you're taught, etc. And in some cases they dignify it with some deep theory, like the random pits, for example. But in other cases, they're just stuck in a tradition which they have no intention of getting out of. And when you get into the commercial sector, you'll find that it's not so easy to get out of them because the whole thing is locked in. For example, in the United States, the minimum excavation investigation by excavation required under their law is a 15% sample by random 1 metre test pits. Well, we wouldn't do that here. And, but here we're just as dogmatic in some of our approaches, believing that the only way to do stratigraphic excavation is to record each context as an individual context and just stack up those in sequence. So I'll have a bit more to say about that. But anyway, that's just a general pie in the sky. Next one, please. Just to annoy people. And then this is the next thing I want to say about excavation is that it's developing all the time. I mean, nothing gets me rashier quicker than people who say, well, nothing much has happened in excavation in the last 30 years. A lot of people do say that. And I say, well, where have you been? Because it has been developing, and it's been developing in a very interesting way. Now, if we have the top of this here, it would explain to you that this, which we haven't got the side of, are dates, started in 1900, going to 2010. And these are mega, macro, micro, and nano. And basically what this means is that the way that the digging done, it can be done on a big coarse scale or a tiny, tiny scale, and so tiny in the case of nano, so tiny that you're recording things you can't actually see at all. And so through the years, we've graduated. To start with, we used to keep the shiny bits, and then we started to keep all the bits we recognised as artifacts. Then we kept the animal bones, then we kept the fish bones and bird bones, then we kept the seeds, the plants, the pollen, the insects, the phytoliths, or bits of plant, lipids, which is stuck inside cooking pots, then isotope signatures like, say, strontium and oxygen in human bone, and then aDNA, dirt DNA, and proteins. Now, every year, something new is happening in the science of archaeology. It's a very, very exciting place to be. So it stopped being a kind of offshoot from a building site, and it's now become much more like CSI. It stopped being a brown coat and started to be a white coat kind of activity. Now, not all these techniques are everywhere, and nor are they appropriate everywhere. But the point is they exist, and therefore when you're designing you've got a bigger palette, a much bigger palette than you used to have. Go on the next one.
Might you say this site is very important, it's not in danger, I don't know where technology is going to go, it's going to move on, I'll leave it alone.
Yes, you can say that, and they often do say that.
Right.
They often do say that. When you argue, particularly if you're arguing on a scheduled site, you have to argue that the benefits from knowing more, the benefits from the research, are going to outweigh the benefits of keeping this conserved. But I would say one thing about your point. This is a very good point, and it's made publicly, so it isn't as though it isn't thought about. And in fact, I suppose the majority would say, yes, you're right, do not dig any site that is not necessary to dig. You know, they would say that. This is really why, when we came to Sutton to dig Sutton, we had a lot of problems. We had this huge public meeting to try and confront the fact that we weren't going to get schedule monument consent because so many people were going to object to us getting schedule monument consent, and those people were professional archaeologists who believed that there should be no research excavation because if you do research excavation, you're spending money that could be spent on sites that have to be rescued. It's not actually true, but you can see how that argument works. Now, I counter that by saying what everybody in archaeology wants is a laboratory for the development of new techniques. These new techniques are going to benefit everybody. They're going to benefit all the commercial sector. So somewhere there needs to be that. You can't do it at any other site. It has to be a site that's reasonably well known, otherwise you'll never get the funding to try out the new techniques. This is the argument that eventually won the day. Objections were withdrawn. There were a lot of objections, and they all were withdrawn, and then we got schedule monument consent, and then away we went. And then we did these gadgets and so on, and tried new ideas, and a few more I'll tell you in a second. Okay, so here's the kind of diagram that you certainly won't be able to see in that corner, but it very quickly, it gives you levels at which excavation can take place. Now this is a very, very simple idea. All it means is that what you see depends on how you try and see it. So if you use a bulldozer, you will see something, but it won't be very precise. You'll see only coarse things, and you'll only get big finds that are thrown up by the bulldozer. If you use a shovel, then you'll see more, and you'll get more finds. If you use a trowel, you'll see much more, and you'll see many more finds. And if you start sieving and use a trowel, you'll see more still. And if you start doing it minutely with a little brush and spatula, you'll still get more information. And so it goes down into the nano sector. Okay, now this is common sense, I know. It also very much affects the funding. So it's relatively cheap to move square meters of earth with a machine compared with doing it by hand. And the more that you're asking people to do it slowly, the longer things are going to take, and the more people you need to do it. So when you're constructing a kind of business plan for getting an excavation working, you bear these things in mind. And in your project design, you try and introduce the concept that some of the site, let's say the first 3 feet, the first metre, is going to be removed by a machine, level A. Then I'm going to clean it up with a shovel, level B. Then I'm going to expose the top with a trowel, level C. And then I'm going to dig the features I see at level D. Now all these are going to cost different amounts. And if you're going to say, well, how do you know that in advance? The way you know it in advance is by evaluation, or that is to say, taking a sneak preview of the deposit. Now here you have a sneak preview. You also had a previous preview, so to speak. So we had a pretty good idea of how deep you're going to have to go before you get, say, to the platform of wood or to the causeway. So you know that soil is pretty mixed because people have seen it before. So the machine comes away and takes off the first metre of the site that you were looking at today and drawing its section. Okay, well, let's not go into this in too much detail, just to make the point that, of course, the more care you take with the digging, then the more care you take with the recording. So you don't waste a lot of time drawing in immense detail things which don't have edges that have been properly defined. They've only been shovel cleaned or machined. same goes for the amount of material that's recovered. So I swear by this because I think it gives you very good control of what you did. And our recording sheets, which you'll come across, not you won't come across ours, but you come across some recording sheet, ours carry the recovery level on the top right-hand corner, just to remind people of how that particular context was recorded. Next one, please. Okay, so here's some people in action. Sutton Hoo. It's been machined off. There's some people shovel cleaning it. There's some people troweling it clean, aided by one of these kind of portable sprayers that we built. We were digging on sand, dries very, very fast. And so we had to try and keep it down, so it's workable, so it didn't blow away, and so that we could see the colour contrasts in the soil. And then when the graves were exposed, then they were dug in levelly. Next one. Okay, so here are some level A people high-macking away. These are some Russians in bikinis with their graders. That's a serious machine, that is. And they drive them straight through the middle of their burial mounds, the curtains, and then record the sections, which have bodies in. That's us at Sutton Hoo. There's Madeleine on a dumper. And this is London breaking up concrete in a basement so they can get at the archaeology underneath. So you have to know a bit about machines before you become an excavation director, and what they can do, and how to handle them, and how to handle them safely. Next one, please. So here are some level B diggers. Here we are emptying a deep ditch around a church in Castelsepprio in Italy. Here we are using rakes to break up the surface before surface collecting. This one, we have ploughed the surface of the ground by backblading with the tooth of a bucket, and picking up fines. Next one. So we go through there. Okay, now we're level cleaning here. Level C cleaning with trowel and brush. Next one. Different sites. Now we're starting to do it in very much more detail, using trowel and time really to try and get a beautiful definition. Next one, please. Well, the person who taught us how to expose the surface of an excavation was really Brian Hope Taylor, and he did it at this site at Yevering. Extremely well done, very, very thoroughly published. From the air, there were these halls shown from the air, as well as this kind of theatre thing here. They're going to reconstruct this theatre at Beaton's World. And this is one of the halls as cleaned, and there's Hope Taylor's tower. So his technique was to clean the surface, brush it, and then go up to his, wait for the rain. Didn't take long usually in Northumberland in autumn, the rain to fall, nice and damp. Then he'd go up the top of his tower with his camera and photograph it every 10 minutes for 2 hours. As it gradually dried out, the shapes of the building became more and more clear. Not only the shape of the buildings, but within each of these trenches here, he could start to see the position of the posts and where some posts had been pulled out. Now imagine that drying out in a drying wind, and so it all goes grey and you can no longer see it. So sometimes things are quite ephemeral. I mean, I noticed this afternoon somebody was explaining a section, and they were saying things to you which you were having quite a lot of trouble seeing, and wondering, how did he know these things were here? The answer is, well, because it was much clearer before, and you could remember where the cuts were and where the horizons were.
I remember when I called you, actually, and said you were coming here, you said, "Go tower."
I'm always saying that. The commercial sector don't like towers because we've got health and safety problems. But I'll tell you a story. Dave Strachan, who I like very much, he was digging up in Glen Shee. I just visited him last week. And he said, I've got this big pit karmic building. So I said, well, get a tower so you could see it. And so he got a tower. When I got there, it was like a typical day in Glen Shee. The cloud was so thick, all you could see was the top of the tower. From the top of the tower, you could see the cloud. So he said, I've got a tile. I said, well, I'm sure you'll have a better day than this to use it. Next one. So that's Yevering. And this is Port Mahomet, there's our tile. And you can see the kind of effect you get here. It's absolutely amazing. You're making a very, very detailed map. And the way that's recorded is usually by overhead photography and then surveying in the edges using little tags to mark off the edge of the features. Next one, please. So these, and this is at Rosetown 2 in Ireland, one of the great commercial enterprises of Europe of our day has been the National Roads Authority, who've spent millions and millions of pounds excavating in advance of road schemes in Ireland. And those millions have been very well spent because they brought in very good archaeologists, homegrown and from overseas. And those archaeologists have used good techniques to produce very vivid pictures of Ireland from the Neolithic onwards. Next one, please. Well, that's all very well if you're working on the flat, but when you get deep sites, you have different kinds of problems because the features all cut into each other. In your site, I think you'll hopefully find that there's not a lot of that. Well, hopefully. I mean, you may not find there's a lot of that. You find that there's a ditch one place, post holes, and so on. But if you dig in a town, everything's on top of everything else. They're all cut through really hard. And the old way was just to sort of slice it and hope that the section would tell you everything. The new way is to take everything apart, dissect it layer by layer, context by context. Next one, please. And if you do that, that's good. It's the right way to do it. But of course, if you just do that, then you only record the physical deposits, and as you take them apart from each other. What you don't record is the thing itself. So a feature on the American definition is an artifact that you can't take home. I think it's quite a nice definition. It is an art. Context isn't an artifact. I mean, it could be man-made, but it's really just a deposit of stuff. It's earth, it's dirt. Whereas this is something which has form. And you need to record that too. So if you only record the context, including only the edge of this, then that's not enough, in my view. So that's why I have a conceptual recording system which records all the contexts, and then it records the features which are sets of contexts, and then it records the structures which are sets of features. This is immensely helpful when you're writing up, because you're, so to speak, identifying the dramatis personae of your site as you go. You don't wait till the site is finished and you can't see it anymore. You're identifying the players of the past as you go. Next one. Can't see this at all. It's a section. Next one. the light was badly. But putting those in order, there are lots of techniques for putting these in order. Best known of them is the Harris matrix, which works essentially on one type of stratigraphic unit, i.e. the context. But if you use features and structures, then you can come up with a different kind of diagram here that was it you were asking me about this today? Yes, this is the kind. So very quickly, since we're together in this room, the way it works is perfectly straightforward. There is also a context-only diagram. It's immensely huge compared with this. So basically, this is like what's it called when you it's a compressed version, and you compress it by putting all those contexts that belong together into the same feature. So here, for example, midden 1, midden 2, and midden 3 have about 30 or 40 different layers in them, but we don't need to know that. Well, we know it, but we don't need to put it on this diagram because the midden has quite a short life, and therefore it can just sit there as a feature. And by the same kind of argument, these fence posts here, each one is a feature consisting of a hole and a cut. But together, they make more than simply a row of features. They're a structure, they're a fence, they're something you identify on the site, you see. So what I want people to do is to all the time think creatively about what's going on, and don't fall for this argument that we are so objective that we mustn't ever make anything up. You can't. If you're a human being, you make things up from breakfast onwards, and it's a question of how you do that. Well, how you let your imagination work. The imagination's got to work, otherwise you can't communicate with the people that you're trying to dig up. So you've got to try and make them into something resembling what they were doing and what their life was like. And your tools are scientific ones, but the way you do that is you have concepts like features and structures to work from. Okay, that's next one. Now, when you get down into more difficult things, now why would you do this? If you start looking at certain kinds of features like a grave is a hole in the ground which has a fill, so it's like any other pit in some ways. But we want to know rather more from a grave. We know that already, so we're allowed to think. Thinking is always allowed on the excavation. We're thinking, I can get more out of this grave. How will I do that? I change down my gears to level E. I'm going to dig more slowly, more carefully, and I'm going to record more, because I want to know more. I want to know everything about the person who's buried there. I want to know not only everything about their body, insofar as that's survived in the form of bones and so on, and any grave goods with them, but I want to know how they were buried, what the burial rite was. The secrets to the burial rite, the actual day of burial, they're all in the backfill, the bit you tend to get rid of rather quickly. You shouldn't get rid of it quickly. It's got to be slowly explored for its anomalies. They'll tell you how that grave was backfilled, whether it was done usually or suddenly or whatever. Okay, next one please. So here we are. Look, just put out a row of tools here. So you get down to this kind of detail, and you're dealing with dental picks and wooden spatulas, all sorts of things. It's a lovely, lovely thing to do. If you ever get a chance to dig a grave, it will be the most exciting day, 2 days.
So is that someone suspended over the grave?
Yes, that's a piece of scaffold, it's just scaffold poles. And basically these are on planks on sandbags. And then there's a cot mattress there which she's lying on. And so she doesn't have to touch the grave, she just looks down and reaches her tools. Next one, please. Okay, and here's a particularly brilliant excavation done an amazingly long time ago, in 1980, by a brilliant Swedish archaeologist called Dagmar Gilling, and there she is in her dark glasses here. She dug a big burial mound at Högum, which means mountains, in Sweden, and found a burial chamber and decided that this burial chamber should be dug in the laboratory. And basically what had happened was that the roof of the burial chamber had collapsed and made a kind of thing which had turned into a kind of plank. It was absolutely solid, but you could see the impression of the finds in it. So she just squished everything into this block. So she lifted the block and took it away in a lorry, and then put it on a big slab inside a laboratory. No wind, no dirt, everything clean, and then she could dissect this burial. This is the result. One of the most interesting 5th century graves that has been found, and one of the best excavated. Next one.
Can I ask a question? How different do you think it would have been if she hadn't done it that way, and if she hadn't excavated it in the lab?
Well, I think when they started to try and get rid of the wood, they found that they actually had to chisel it. So by chiseling the wood, you were going to chisel through sword, little buttons on swords, all sorts of things. So they would have done a lot of damage doing it that way. But what they did was, when they took it to the lab, they turned it the other way up, so that you were digging from the subsoil down, you see what I mean? And so that the soft bit was on the top. They still had a problem with the wood when they got to it. By that time, they'd managed to pick the finds out of the wood, but because everything would be. The other thing they did, well, one of the very first times this ever happened, they did an X-ray of the whole chamber, of this whole kind of wafer, this flat plank. They X-rayed it in real time and took photograph of the whole thing, laid out the photographs, and then when they finished the excavation, they laid out all the X-rays like that, and then they laid the finds on top of them, the ones that had been seen. Brilliant piece of work, way ahead of its time. Next one, please. Okay, well here's a case where there wasn't anything left. This is Mound 2. Mound 2 had excavations in 1860, 1600. It was burials about 625. It had excavations in 1938. There's see all these Chinese boxes here, what's been, the different excavators have cut their way into this grave, so there wasn't much left in it. But it did seem likely that the residues from the finds and from the body would have sort of soaked in to the chamber floor. So although we had a blank chamber floor here, this is a Sutton Hoo one, and we took these 640 samples which contain elements, and those elements were recognised by a machine at Queen Mary's College in London. It's called inductively coupled plasma spectrometer. You know? And what it does, it not just doesn't measure, it doesn't only detect the cations that are there, that's the metal elements, but the quantities. Next one. So this shows you roughly, so it's a very rough case of what there was. And you can see some things are pretty recognisable. A big splurge of copper cauldron, a wiggly bit of iron chain, and then this end was the body. Aluminium, lanthanum, strontium, phosphorus, barium were diagnostic elements of a vanished body, and it so happened we knew that because we excavated some graves which had just got these ghostly figures in, made of sand, so and we had them chemically analysed. They said, oh, this is what you're looking for here. Okay, next one, please. Now, we have lots of situations where there are layers, but those layers are extremely hard to see. And yet, we know these layers are very significant for the passing of time and for activities. Thinking particularly now of Paleolithic sequences, very, very old sets of strata. Now, you can see some interfaces here, but they're all a bit strange, and a lot of those interfaces are due to very much later effects of drainage. So they're making layers, they're making interfaces, but they're making it because there's water pouring off the top of the roof. One of the ways this is being addressed now, next one, is by using magnetic susceptibility on the section. So it's not using it to find sites. I know it's a geophysical technique, but it's using it to examine the section. This chap, Andy Herries, is one of the leading lights who's doing it. And basically, he can group types of deposit, colluvium, this is Middle Stone Age deposits, and fire deposits. Hearths are what they're looking for. Because in the Paleolithic, life is, well, interminable really, and what punctuates it is a fire. Okay, let's build a fire. That's why we love fires. That's why we like having campfires. That's why you like having fires on your campsite, because there's an atavistic feeling of, God, I've had a long day hunting things with my barbed and tanged arrowhead, and now I want to sit around a lovely fire. So the hearths punctuate those sequences, and those hearths are episodes of visits, hunting, etc. Now the trouble is that they are actually quite hard to find, because you can find stones, and sometimes you find stones in a ring like this, but they're not necessarily hearths. And the way the MagSus finds it out is by looking at the direction of the magnetisation. And basically, if it's been heated, all the magnetic fields go in the same direction. If it hasn't been heated, they don't. So by measuring that, you can tell the difference between a hearth and tiny stones. Come on, this is clutching at straws. Yes, it is. But you're dealing with a period very remote where the evidence is very, very elusive. Next one, please. Okay, so there's Graham Barker. I just put that in for Catherine, and he's busy taking a section. He's taking a monolith out of a piece of ground in the jungle. Now this stuff is very, very aggressive. It's like garden soil. You know, you pick up a lot of garden soil. It's all mixed. It's notoriously free of any strata. Okay. Now imagine 100,000 trees on top of that, all with their roots, all with their little microbes working away. This soil is a mass of live animals all eating each other. That's the jungle. And so it's extremely hard to see anything. Next one, please. And the way that they've addressed this now is to make soil blocks and X-ray them. That's a new thing. The old days you used micromorphology or something like that. We still do. But this X-raying is very nice. You make a sort of thin slice like that. And the X-raying shows you the roots. And it shows you at which level the roots were growing. And those roots are recognisable as special roots, like cereal roots. Next one. Next one. Yeah, here we go. So these help. In fact, this is on Cook. This isn't actually in Borneo. This is Tim Denham's site. And here is a deep, wet forest superseded by agriculture with soil mixing in food plants, and then the dry forest returns after that. Nice little sequence, nice little storyline from quite a small hole, high tech. Next one, please. This is a site at Lyra, which is actually a reconstructed building, and they decided to see whether they could see whether cows had lived in it. So they put some cows in it, and then took the cows out, and then did a plot to see whether they had any traces of cockroach stannuls, which in human speak is cow pads. So basically, yes, here are the humans, here are the cows, it comes out on the chemical mapping of the floor. Next one, please. And this is the work of another of Catherine's students, Karen Millet, who did a super thesis on that kind of thing, plotting the activity inside a building. It's not enough just to get the outline. Next one, please. Of the outline of the building. These are Viking houses, by the way. Built of turf and stone, hearth in the middle, and then lots of this ICP, that's the chemical mapping, acidity, loss on ignition, organic matter, MagSus, electrical conductivity, a whole battery of techniques now. This is all the CSI world. And what they're doing is looking at the floor of the house to see how it was used by the Vikings. Next one, please. Keep going as some results. And here is, next one, a Viking house with the different bits. The areas used, there's the hearth, there's the storage, there's the loo, the lavatory in the corner there, there's a grass bed, wool washing and dyeing, really interesting. Lots and lots of good chances here of telling an intimate story about what Vikings are doing in their houses. Now, you wouldn't necessarily think of putting this in if you were excavating this, even if you had to excavate in front of a road scheme. But you could blow the whistle. You could say, no, come on, let's do this properly. And the developers have got money. All they need to know is why you want to do it. There's the answer. Next one, please. Well, this is my last example in the nano world is dirt DNA, ancient dirt DNA, AD DNA. His example comes from Greenland. It was an excavated. The site was excavated. It's known as the farm beneath the sand for obvious reasons. The founder's farm. And they did the excavation and they found lots of animal bones. Next one, please. Now, what these guys thought they'd do is take a single column from there was a field quite near this site, and they took a column through it like that, and then they took samples at intervals all the way down this column, and then had them analysed for DNA. Huge amount of precautions were taken to make sure that nobody contaminated. In fact, they contaminated it themselves with a certain set of DNA on the outside to see whether it got on the inside. Sent it to 3 different laboratories, and then came up with the quantities of mouse, reindeer, human, sheep, goats, cattle. They chucked the human because they were so worried about contamination. They had a pretty good idea that there wouldn't be too many goats around in the laboratory, and so they could do these species, and there they are, from 1040 to 1100 AD to 1440 to 1520 AD, when the Scandinavian occupation of Greenland kind of petered out. That's amazing. At the bottom you can see the DNA sequences. So a really extraordinary kind of white coat. You imagine where this will lead in the future, because people will be able to take their, yeah.
They're literally
putting a core in and extracting tiny bits of skin or
Well,
fluff or whatever out.
Well, it's basically what happens to the animal droppings in Greenland. I'm not saying it will work in the jungle because there's such a lot of soil mixing, but the soil in Greenland isn't worked, you know, there's not millions of worms and so on, so it's not works, it tends to stay where it is. So your flocks accumulate with droppings in dung. They accumulate a certain amount of their own DNA, which they have now demonstrated, I think, quite well, doesn't move very much. I just don't think it would work everywhere, but if it works in this kind of, see, if it works here, it would work in Mongolia. Now there's an area which really badly needs exploring on a huge scale. So, you know, two men in a truck with an auger could go a long way to knowing how many animals have been moving over the surface and when, because of course they can radiocarbonate the levels concerned. These are next one. Thank you very much. So that's the general story. Sheep kept going all through the period. The cattle came and then went, and then came back, and then went finally. So the cattle were very much more vulnerable to climatic change than the sheep. And this tells a story of what the Vikings had to put up with, or what the Norse had to put up with in this settlement in Greenland. Next one, please. Well, of course, lots of gadgets are on the market, and here's a couple of them. This is the NRI gun, for engineering companies, Phasia, so-called. This has been used in Sweden for detecting in sections. They can detect bone and textiles, they say. I haven't seen this in action, and I'm not sure I can totally believe it. This is the XRF analyzer. This is much better known. Lots of people have these. You kind of see people wondering about a big holster like this with their XRF analyzer. And if you're not careful, they'll use it on your rig and tell you it's made of zinc. Okay, so these are on the way, and where they've been used very effectively is in things like massive glass workshops in Syria, where they use something like the XRF to detect the chemical signatures of the glass as it's in the ground. So you do that as a kind of survey. So you've got opened up a great big area like this, you've got kill, lots of glass, test the glass while it's still in the ground for its composition, and that shows you've got these kilns which are working a certain type of glass, and these kilns working another type of glass. It all comes from this particular glass factory, but hitherto no one realised that it was made in the same place. Okay, next one. Okay, so that was our little travel. We're not going to look at analysis and publication. Next one, please. I'm going to draw to a close, and I'll just say something a little bit about that. Anyone want to ask any questions about any of that stuff so far? I've got about 4 or 5 more pictures, that's all. So. Okay, you're happy. Well, let's suppose this system is reasonably effective. The question is, how can we apply it socially so that our profession gets its chance to find out about the past in partnership with, or at least with the permission of, the society that we live in. You probably know that the way commercial archaeology works is that developers, people who are building something, do a deal with archaeologists, or these days more often with consultants, in order to decide how much archaeology shall be done. and the archaeologists are often negotiating for time and money. I think this hopefully will begin to become a little bit more sophisticated, and archaeologists will start to negotiate more for the benefits to the community and the benefits to the developer too of what they're doing. In other words, not that it's not back off I'm a scientist, it's more we are people who are doing things which are of interest to everybody, including your board of directors. And we can show this in very many different ways. I'm mentioning this now because it's 80% of all the students who go to university and come out and become archaeologists go into the commercial sector. They don't become academics, they don't become lecturers, they go into the commercial sector. And it's a great place to be. And I know there are lots of problems, and every time the building industry sneezes, we catch a curve. I know that. But the point is, it still can be a brilliant way to spend your life, right up until the point where you get arthritis at 43. Next one, please. So that's what's going on in the commercial sector. This is some of the professional work. This is what you call a bit of a bum contract. In this case, they're having to dig the chemically saturating deposits just by the river Foss, and trying to make archaeology happen there. Very hard. Next one. So the way I see this working is that you have to bear in mind that there are people who do lots of thinking about the past, and people who do lots of digging and really care about how digging is done. And there are people who care about the conservation, people who care about the heritage, people who care about public participation. All these are aspects of our community, and we all like each other. We don't necessarily want to do what the other person's doing, but we like the fact that there are these people doing different jobs. And so we try and get together. We do it socially when we're at university, and then we tend to kind of drift apart as some go to work for county councils, or some go into universities, and they all get way down with the particularities of that form of employment. It happens, and it happens in other kinds of subjects too. We're not the only people who do this. Nevertheless, I think we could do with seeing a bit more of each other and kind of drinking in the same pubs. It seems to me that one of the problems with design is that they do tend to be a little bit too personal. They don't get enough airing before we decide what we want to do. We don't really ask enough other people. It needs to be much more like designing, putting a film together, putting some big creative enterprise together. Universities are always interested in new discoveries about the past. They don't show it very often, but they are interested, and they ought to be more interested. They ought to be, so to speak, willing partners of every new venture. More often you have to dig them out of their offices and try and beg for their help. But in theory, they've got the back knowledge, which is what you really need when you're putting a design together. Then there is the question of local archaeological societies, and this is, I need to get on my hobby horse for a bit and ride away. This is because I believe in local societies. I've spent most of my career lecturing to local societies, perhaps 12 a year, and those are people who are very interested in what archaeology is doing. So while many people are sitting at home watching Time Team, others are out in a village hall somewhere meeting a real archaeologist and talking about real excavations that are really happening at the moment, all their problems, and what they're finding. So it seems to me to be self-evident that every single archaeological project that happens in the field should have a local society involved in it, giving it added value. Now, I know there are problems. I know the commercial sector says, we can't have people, we can't have the public, there's health and safety, there's all sorts of problems. But actually, a local society isn't that. A local society is an agent. It's your local agent. You go to them and say, first of all, where are the local records for this area? that I've just won a contract in? Where are the groups who like to work in the field? I'd like to be put in contact with them. And maybe you could do a bit of filtering for me. Let's put the ones that are not in a digging frame of mind. Let's put them deviling away in the library, looking up the land records for this piece of land. And let's have the ones that are really keen to dig well, let's have them along, and we'll train them up as volunteers, just as you are doing here. But those local societies are left out of so many contracts. The majority of contracts, in fact, in this country don't have anything to do with it. Even if they have what they call a community element, they still don't have the local societies, and yet that's what these people exist for. So I urge you to try and find them wherever they are, and I'm sure you are here, but I think when you're doing a commercial job, just as when you're doing a research job, you need these guys. So they together generate the archaeological design. This is a nice head-banging evening, sorting out what we'd like to do from everybody's point of view, and then away it goes, it gets accepted, it gets the money, and it produces fantastic new archaeological research. Next one, please. So that's the end, and here's my take-home messages. That what we do in the field, archaeological investigation, whatever we do, depends on good design, not just standard procedures. The good design is a design that needs to be published so that we know what's going to happen before it happens. It takes account of the objectives, the terrain, and the social context. The modern approach is always combined survey excavation. And now, at different scales, from the highly visible, the things you can shovel, to the invisible, the things that you can only detect because they're at the molecular scale. The cost, for me, should not be the cheapest. It should match the best design. Now this is like moving a mountain, because unfortunately the whole of British archaeology works on competitive tender. The whole of the commercial sector works on competitive tender. But it shouldn't do. We're not that sort of a subject. We're not like procuring gravel. We are investigating the past. And we are creative, the same way as an architect. In the same way as an architect is given the chance to produce a design, and somebody judges which is most appropriate. So, archaeologists should produce designs, and somebody should judge which is the most appropriate. And then lastly, we're always a collaboration. We always should have, not just the archaeological contractor, not just the local authority, we must have a university, and I think the local society too. And that's what makes great archaeology. And you are making it here, and I congratulate you.